All right, guys, Mr. Antonucci here, and in this video, we're going to talk about the power rule for functions. Stay tuned till the end because I have some AP-style questions to go over with you. First, let's establish the general rule. So the derivative of a function to a power is just equal to n times that function to the n minus 1 times the derivative of that function. If we think about it in terms of f of x equals u to the n, where u is its own function, then f prime of x is going to be n u to the n minus 1 times u prime. So just a couple different ways to look at it there. So let's go over an example. In this case, the function is 3 minus x cubed. So the derivative is negative 5 times 3 minus x cubed to the negative 6, remember subtract 1 from the exponent, times the derivative of the inside, which is negative 3x squared. Cleaning this up a little bit, you would have 15x squared times 3 minus x cubed to the negative 6. In this example, I want to go over something that's very, very important to understand. In this case, the cube is on the cosine, so this is the same as cosine of theta quantity cubed. If it were cosine of theta cubed like this, that means cosine of theta cubed like that. Okay, so if the 3 is on the cosine, it means the cosine function is being cubed. It really helps to rewrite it like this because then you can see this is the power rule for functions. F prime of theta is going to be 3 cosine theta squared times the derivative of the inside, negative sine theta. We could clean this up by writing it as negative 3 sine theta times cosine squared theta. Now, in this case, same type of situation, we have sine cubed theta, which is the same as sine theta cubed. The theta is not cubed, the sine theta is cubed. So dy dx, the exponent comes down, multiplies the 2, gives us 6 sine squared theta. We subtract 1 from the exponent. The inside is the sine, so the derivative of that is cosine theta. Now for this one, we're getting a little bit more complicated because you notice that you have a function to a power, the x squared plus 1 is being cubed, but it's also multiplied by e to the x. So this is a situation where you have a product rule. The e to the x is your first, and this quantity cubed is your second. And when we go to differentiate the second factor, we would have to use the chain rule. So we'll go through this a piece at a time. The derivative of the first is e to the x times the second plus the first, e to the x, times the derivative of the second. Now, to get the derivative of the second, x squared plus 1 cubed, you would have to use the chain rule on that for a general function. So 3 times x squared plus 1 squared times the derivative of the inside, which is 2x. Now, we could simplify this a little bit. It's not necessary, but on the AP exam, sometimes if this were like a multiple choice question, they might simplify it. So we could take an e to the x and an x squared plus 1 quantity squared out of both of these terms. And then that's going to factor everything out of this first term except one more factor of x squared plus 1. And then everything's going to get factored out of this second term over here except the 3 and the 2x, which are going to multiply to 6x. So you might see the answer as e to the x times x squared plus 1 squared times x squared plus 6x plus 1. Now, here's another situation where you have a function to a power, but notice that the inside function is a quotient. It's a rational function. So this is an example where we have a quotient rule inside of g prime. The inside is the quotient. The outer function is the power function. So we'll use the power rule for functions. It's going to be 5 times that function to the fourth times the derivative of the inside. Now, we would have to use the quotient rule. So the denominator squared, then the derivative of the top, 3, times the bottom, 4x squared minus 5, minus the top, 3x plus 2, times the derivative of the bottom, which is 8x. We could simplify this further algebraically. It's not necessary at this point, but just know that if this exact question were on the AP exam and it was multiple choice, the choices may be a simplified form of this. However, if this were a free response question, this would be good enough. Here's another situation that could come up. Notice this is a power rule for functions because you have a function, x squared sine x, raised to the fourth power. But notice the x squared sine x is a product. So this looks like it would be a product rule inside the power rule. But since you have a product, we can actually simplify this as x to the eighth sine to the fourth x. And we could just get h prime using product rules. So derivative of the first times the second plus the first times the derivative of the second. Now you will need to use the chain rule on sine to the fourth x. That's just a general power rule. So 4 sine cubed x times the derivative of sine, which is cosine. All right, now we're going to go over a couple AP style questions here. So for this one, if f equals 1 plus x over 20 to the fifth power, find f double prime of 40. This little Desmos symbol right here means that we can use Desmos. Little tip here, don't waste time trying to algebraically figure out the second derivative of that function. Just pump that function directly into Desmos and then use the prime notation and get f double prime of 40. All right, so here's f of x. We don't even need to worry about the graph. We can literally just type in f double prime of 40 and you get 1.35. That's going to be our answer. So if we go back here, notice it's choice B. Good stuff. Okay, one more AP style question here. Let f of x equal x times g of h of x, where g of 4 is 2, g prime of 4 is 3, h of 3 is 4, h prime of 3 is negative 2. Find f prime of 3. Woo! So if we want to take the derivative, f prime, they do this a lot where they mix function notation with some variables in there. But the key is to recognize this. This is x times a composite function. So this is a product rule with a composite function in it. So derivative of the first is 1 times the second, g of h of x, plus the first times the derivative of the second, which we would use the chain rule, g prime of h of x times h prime. And then we want f prime of 3. So this would be g of h of 3 plus 3g prime of h of 3 times h prime of 3. We know h of 3 is 4, so this h of 3 is going to be 4. And then g of 4 is 2, so this is going to be 2 plus 3 times. Here we have h of 3 inside g prime, and we know h of 3 is 4, and then g prime of 4 is 3. So this would be 3 times h prime of 3, which is negative 2. So this is 2 minus 3 times 3 is 9 times negative 2 would be negative 18. So negative 16, choice B. All right, guys, that's it for this one. Hope that was helpful to you. Write a comment down below and let me know which of these was your favorite question. And also make sure you subscribe for more AP Calc videos.